This week on the show, we look at how Netflix serves 100 gigabits per second from an Open Connect appliance. We read the FreeBSD status report for the second quarter and show you a FreeBSD update speedup via nginx reverse proxy. And for the OpenBSD folks, we have a little customizations for the default shell. So everything that you need to know about BSD. Now. BSD Now, episode 215, turning FreeBSD up to 100 gigabits per second. Recorded for the 11th of October 2017. Hi, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And another week, another great show prepared for you. And the headlines are very interesting this week because serving 100 gigabits per second from an Open Connect appliance sounds very interesting. And this is, of course, over at Netflix. And Alan will have the latest news for you.
Yes. So this is over at the Netflix Tech blog, a post by FreeBSD developer Drew Gallatin, who works on the Open Connect Appliance team at Netflix. So it starts off, in the summer of 2015, the Netflix Open Connect CDN team decided to take on an ambitious project. The goal was to leverage the new 100 gigabit Ethernet interfaces that are just coming to the market in order to be able to serve 100 gigabits of traffic from a single FreeBSD-based Open Connect Appliance machine by using NVMe Express or NVMe-based storage instead of spinning hard drives or regular SSDs. At the time, the bulk of the flash storage appliances that they had built were close to being CPU limited, serving just 40 gigabits per second from a single socket Xeon E5 2697 V2, which is very much the high-end Intel CPU. The first step was to find any CPU bottlenecks in the existing platform while we waited for Intel to come up with the next generation of CPUs. Newer motherboards would also have PCIe Gen 3 X16 slots that would be able to run the new Mellanox 100 gigabit network cards at full speed and have PCI bandwidth left over to do NVMe devices. So they went through a number of iterations as they walked up from 40 gigabits to 100 gigabits. The first one they did was fake Numa. So if you don't know, Numa is the non-uniform memory access. It mostly has to do with in multi-processor systems and even some single socket ones now. There are multiple domains. So normally you have, in a multi-processor system, you'll have, two sockets on the motherboard, and there'll be RAM slots that are connected to each of those CPUs. If you're a program running on the first CPU, accessing data that's in the RAM that's connected to the second CPU requires you to go across the interconnect to that second CPU and then access the RAM, which is slower than accessing RAM that's connected to the same CPU that your process is running on. And using all this information, you can teach the operating system to do things like allocate the memory for this program from RAM that's closer to it, or even move this program so it runs on the CPU that's closest to where the memory it needs access to is. And the same goes for your PCI devices. So your different PCIe slots are going to be connected, usually alternatingly, to the different CPUs. So if you want to receive packets from the network card that's connected to the second CPU, you probably want your nginx that's doing that to run on the CPU that is closest to the network card.
No detours.
So what Netflix did was fake Numa. So normally most of their OCA content is served from disk. Only 10 to 20% of the very most popular titles are served from memory. And they have a link to a previous blog post where they go into more detail on how that works. However, our early pre-NVMe prototypes were limited by disk bandwidth. So we set up a contrived experiment where we served only the very most popular content from one specific server. And they filled that server with RAM. And we allowed all content to fit in RAM and therefore avoid the temporary disk bottleneck that they were running into. Surprisingly, the performance actually dropped from being CPU limited at 40 gigabits per second to be CPU limited at 22 gigabits per second. So they were like, what? How is serving from RAM slower than serving from disk? The ultimate solution we came up with is what we call fake Numa. This approach takes advantage of the fact that there is one set of page queues per Numa domain. So it turns out they were spending all their CPU waiting on access to the page queue. All we had to do was lie to the system and tell it that there were one fake Numa domain for every 2 CPUs, instead of just one domain covering all the cores. After we did this, our lock contention nearly disappeared, and we were able to serve up to 52 gigabits per second, which was the limit of their PCIe Gen 3 8X slots, with substantial CPU idle time. So by breaking up the locks into a bunch of separate sets so that different CPUs wouldn't be waiting on each other, they suddenly managed to increase the throughput. After that, they had newer prototype machines with the new Intel E5-2697V3, which, if I remember, has a couple more cores and quite a big, beefy upgrade. On top of that, the motherboard now had PCIe Gen 3 X16 slots, which allowed their 100 gigabit NIC to work at full speed, and support for up to 4 NVMe devices and 44 SATA SSD drives, right? Because they're using, I think, PCIe NVMe, so it was either they put in the 4 NVMe's or they put in controllers to connect to up to 44 SSDs. At that point, they hit a different bottleneck, also related to locks on a global list. We were stuck at around 60 gigabits with the new hardware, and we were constrained by pbuffs. So our first problem was that the list of pbuffs is actually very small. We spent a lot of time waiting for those pbuffs because they were all in use and you had to wait for a free one. This was easily fixed by increasing the number of pbuffs by setting a kernel tunable to increase the number of pbuffs allocated at boot. However, this update revealed the next problem, which was lock contention on the global pbuff mutex, because you can't have multiple people writing to the list at once. To solve this, we changed the vnode pager, which handles paging to files, so rather reading data from files into memory when it's needed, and it handles all the send file I/O. So when the web server says, hey, kernel, please read this range of bytes from this file and send it to this socket, what sendfile does is call up the vnode pager and I need these bits of this file loaded into memory so I can use them. And once they're in memory, sendfile then shares that down to the mbuff, the network buffer, and then that goes out to the network card and so on. To solve this, they changed the vnode pager to use the normal kernel zone allocator instead of its own separate memory setup. This change removed all the lock contention and boosted the performance into the 70 gigabit range.
We're getting there, yeah.
So they're slowly getting there, one bit at a time. And of course, I'm just covering the highlights here. There's a lot more detail in the blog post. So if you know what some of this stuff is or are interested, it's definitely worth going and reading about it. So as noted above, we make heavy use of the VM page queues, especially the inactive queue. Eventually, the system runs short on memory because you're paging all this stuff into memory in order to send it, and then, it ends up sitting there for a while until you need more memory and eventually have to free it. So the system runs short of memory, and these queues need to be scanned by the page daemon to decide which ones can be freed. At full load, this happens roughly twice per minute, but when this is happening, all the nginx processes would go to sleep in the VM wait function, waiting for more memory. And the system would stop serving traffic while the pageout daemon worked to scan the pages, which would often take several seconds. This problem is actually made progressively worse as one adds more Numa domains, because there's a separate pageout daemon per Numa domain. But the page deficit that it's trying to clear is calculated globally, right? We don't calculate how much memory is free for each Numa domain. We just know how much memory is free for the whole system. So So if a VM pageout daemon decides to do some cleanup, say 1 gigabyte of memory, and there are 16 domains, all 16 of the daemons will individually attempt to clean up 1 gigabyte of memory. So suddenly, you're pausing everything while you're clearing 16 gigs of RAM and then going back to sleep. And then you do some more work until you run out of RAM, and then you do this big work again. So to solve this problem, we decided to proactively scan the VM page queues. In the send file path, when allocating a page for I/O, we run the pageout code several times per second on each VM domain. The pageout code is run in its lightest weight mode in the context of one unlucky nginx process. All the other nginx processes continue to run and serve traffic while this is happening, so we can avoid the bursts of pager activity. So instead of waking all 16 of them up, doing a bunch of work, and then continuing, we wake one up at a time, stalling at one nginx process instead of all nginx processes. Proactive scanning allows us to serve roughly 80 gigabits on the prototype hardware. So they're getting there, but then they have, still a bit to go. So then, Hans-Peter Selesky, who's the Mellanox 100 gigabit driver developer and a FreeBSD committer, came up with the innovative solution to our problem. Most modern NICs will supply a receive side scaling, or RSS hash, result to the host. RSS is a standard developed by Microsoft, wherein the TCP IP traffic received on the NIC is hashed by the source and destination IP address and/or the TCP source and destination port number. The RSS hash result will always uniquely identify a single TCP connection. Hans's idea was, rather than just passing the packet to the LRO, or large receive offload, which is a function in the NIC that tries to group a bunch of packets together and hand them to the kernel at once instead of one packet at a time, which can make a big difference when you're receiving, thousands or tens of thousands or hundreds of thousands of packets per second. Yeah, so Hans's idea was, rather than just passing the packets to the LRO engine as they arrive from the network, we should hold the packets in a large batch and then sort the batch of packets by the RSS hash result, which is, and the original time of arrival to keep them in the right order. But after the packets are sorted, packets from the same connection are now adjacent to each other. They're in order, even when they arrived at very different times. So therefore, when the packets are passed to FreeBSD's LRO routine, it can then aggregate them and do all the work for those packets at once, instead of do it for one, then go do somebody else's, and then come back and do it for the next one, and then do somebody else's, and come back and do it for the third one. With the new LRO code, we were able to achieve an LRO aggregation rate of over 2 packets per aggregation, instead of 1, basically. So 2 and a bit instead of 1 is a big improvement for them. And we're able to send at well over 90 gigabits per second for the first time with our prototype hardware for mostly unencrypted traffic. So our job was done, right? Or was it? The next goal was to then achieve 100 gigabits while serving only TLS encrypted traffic. So they could do over 90 gigabits, so they were pretty much to 100 gigabits. The interface can't actually do 100 gigabits all the time. Yeah. Right. That's the physical limit. So 90 and a bit is about as much as you're going to get, because you don't want to go much more or you just get contention. But that was all unencrypted. Now they want to encrypt it, which is a lot more work. By this point, we were using hardware which closely resembles today's 100 gigabit flash storage-based OCAs, which was 4 NVMe PCIe Gen 3 X4 drives, 100 gigabit Ethernet, and a Xeon E5 V4 2697A. With the improvement described in the Protecting Netflix Viewer Privacy at Scale blog entry that we covered before, we were able to serve TLS-only traffic at roughly 58 gigabits. So they made it all the way to 90, but once they start encrypting it, they're now back down to 58. In the lock contention problems we'd observed before, the cause of any increased CPU usage was relatively apparent from the normal system-level tools like flame graphs and dtrace and lockstat. the 58 gigabit limit was comparatively strange. As before, the CPU would increase linearly as we approached as the bandwidth went up. But then, as we neared the limit, the CPU usage would increase almost exponentially. But the flame graphs just showed that everything was taking slightly longer, and no apparent hotspot. No operation was taking massively longer. Just every single operation was taking a little bit longer. We finally had a hunch that we were actually limited by the system's memory bandwidth. So they used the Intel performance counter monitoring tools to measure the memory bandwidth that we were consuming at peak load. They then wrote a simple memory thrashing benchmark, which used one thread per core to copy between a large memory chunks that would not fit in the cache. And then, according to the PCM tools, this benchmark consumed the same amount of memory as our OCA's TLS serving workload. So it was clear that we were memory limited. At this point, we became focused on reducing the memory bandwidth usage. To assist with this, we began using Intel's Vtune Profiling tools to identify memory loads and stores, so when you're saving and retrieving information from memory, and to identify any cache misses. Because we were using send file to serve data, encryption is done from the virtual memory page cache into the connection-specific encryption buffers. This preserves the normal FreeBSD page cache in order to allow serving of hot data from memory to many connections. One of the first things that stood out to us was that the ISA-L encryption library, which is a library from Intel that provides all the really highly tuned bits for doing this encryption as fast as possible, was using half again as much memory bandwidth for memory reads as it was for memory writes. So instead of being 50% reads and 50% writes, it was like 75% reads and only 25% writes, which seemed odd. From looking at the Vtune profiling information, we saw that ISA-L was somehow reading both the source and destination buffers rather than just writing to the destination buffer. We realized this was because the AVX instructions used in the ISA-L for encryption on our CPUs worked in 256-bit or 32-byte quantities, whereas the cache line size was 512 bits or 64 bytes, thus triggering the system to do read, modify, writes when the data was written. So it would encrypt the first chunk of it, and then when it went to do the second chunk, it would have to read the 32K and then copy it and then write the second 32K and then write all of that back. The problem is that the CPUs will normally access the memory in 64-byte cache line size chunks, so reading an entire 64 bytes to access even just a single byte of the original data. After a quick email exchange with the ISA-L team, they provided us with a new version of the library that used non-temporal instructions when storing encryption results. The non-temporals bypass the cache and allow the CPU direct access to the memory. This meant that the CPU no longer reads from the destination buffer and only writes to it. So with that change, their encryption speed went up to 65 gigabits per second.
Wow, this is fascinating. Pushing the boundaries here and there, getting better tools, better, monitoring and all that. That's very engineering driven.
Mm-hmm. So then, looking at 100 gigabits per second, they're moving about 12.5 gigabytes per second of 4K pages through their system unencrypted. Adding encryption doubles that to 25 gigabytes per second worth of 4K pages, which is about 6.25 million MBuffs per second. When we add in the extra 2 MBuffs used for the cryptocode for TLS metadata at the beginning and end of each TLS record, that works out to another 1.6 million MBuffs per second for a total of just shy of 8 million MBuffs per second. With roughly 2 cache line accesses per MBuff, that's 128 bytes times 8 million, which is 1 gigabyte or 8 gigabits per second of data that's accessed at multiple layers in the stack. Right? Every time there's ALEC, free, crypto, TCP stuff, the socket buffers, the drivers, etc. So it's some pretty impressive numbers.
Yep. And the blog post also has some nice pictures illustrating these concepts and how they all
there's
together.
A whole another section here on MBuffs that we just didn't have time to get into. And and all that stuff. So then we get to, are we there yet? They say, at this point, we're able to serve 100% TLS traffic comfortably at up to 90 gigabits per second using the default FreeBSD TCP stack. However, the goalposts keep moving. We found that when we use more advanced TCP algorithms, such as RAC and BBR, we are still a bit short of our goal. We have several ideas of that we're currently pursuing, which range from optimizing the new TCP code to increase the efficiency of LRO, to trying to do encryption closer to the transfer of the data, so either on its way out of the disk or on the way to the NIC, instead of currently it's done kind of in the middle in the kernel. So as to take better advantage of Intel's new DDIO and to save memory bandwidth. So, you know, they got to 100 gigabits and they're like, oh, now we want to encrypt it. So they get to 100 gigabits and they're like, well, now we want to use a smarter TCP algorithm. And they're like, okay, so we're not quite to 100 gigabits again.
Yeah, but it's certainly nice to see, oh, we hit a roadblock. We found this other way around it. And yeah, a little bit in this section tuning and in the other section, and we're approaching and scratching at the surface. It's certainly a good way to see this illustrated also. I mean, many companies are doing also performance tuning in their own stack or in their own companies, but they don't publish this like the Netflix folks are doing.
Yeah, so it's very nice to see them writing these nice detailed tech blogs, especially, you know, with all the graphics and stuff. You know that this was quite an undertaking to actually, you know,
write up and
draw
put
all
together
the stuff.
Mm-hmm. Yeah, so very cool. And the next story is the FreeBSD April to June 2017 status report. So the second quarter. Mm-hmm. So this is a long list of updates for sub-projects and smaller things. It has a small introduction section. Should I read this quickly or just go over the items?
The introduction here is written by Mark Littiman. He says, FreeBSD continues to defy the rumors of its demise. Much of the development work done this quarter was not particularly visible, especially the effort needed to ensure the upcoming 11.1 release has as few regressions as possible, and it was 11.1 was definitely very successful. And then the planning was also underway by then for the 10.4 release, which I suppose we might not have mentioned came out yesterday?
Yeah.
Right? Or Tuesday?
Yeah, it was this week.
Yeah. Further work focused on moving the ARM architectures support closer to the Tier 1 status and improving documentation. And of course, many other large changes made to the source and ports trees. But again, a lot of it isn't necessarily stuff you would notice. Yeah,
it's behind the scenes work, but eventually it will have a benefit for...
But there were a lot of really important things that happened over that span there.
Yeah, so the report starts with the FreeBSD team reports. So we have a report from the release engineering team, then a report about the ports collection. This is probably from the port manager team, yeah. And then there's the FreeBSD core team report from what we did and some of the ongoing activities, like the FCP process has been announced and all this. So some of these activities are smaller, some of these are longer term who span over multiple months or years even sometimes, but it's good to keep people updated when there's something new or that there's progress being done. Then we have an update from the FreeBSD Foundation, what they did in the second quarter. There's a write-up there, quite a long one. And there's also the Postmaster team, which deals with all the emails for developers and all the mailing lists that we're having in the project. So Postmaster handles all the mail flow for the FreeBSD project, basically.
Yep. Under the project section, we had quite a few interesting things. The first one is, especially if you weren't aware of it already, big change coming in FreeBSD 12 is 64-bit inodes. So the first major change that this provides is the ability to have more than 4 million files in one file system, which, you know, most people maybe don't think about that as being such a big thing, but especially for NFS, it became a very big deal. But the other thing this changes is the maximum length of path names. In particular, the maximum length of a mount point goes up from, I think it was 80 characters to 1,024 characters. If you're a heavy user of ZFS like I am, you could end up with mount points that were relatively long, especially if you created a whole set of data sets inside a jail. So it's like, user jail, host name, dataset, child, grandparent, or whatever. And suddenly it was like, can't mount that. That name's too long. Well, with 12 and forward, that will never be a problem again. Or rather, until you get to path names that are 1,000 characters.
Another goalpost moved.
That's up to you. Even if you're using full Unicode or whatever, that's still 256 characters. That's a long mount point name.
Yeah.
That's a lot of tab complete.
Yep.
And, the original version of that had some backwards compatibility, but then Warner Losh even added forward compatibility to mean that, very few things are going to break because of it. But that project started many, many years ago as a project by Gleb Kurtzu and Kirk McKusick, and then it went on for a while, and then lots of work carried out by Ed Mast, John Baldwin, Giles Turkler, Rick Macklem, Chris Moore doing some testing. Also ports X runs by Antoine Brodin from the ports team. Tests written by Peter Holm, and the last bit of the completion done by Konstantin Belousov.
Yeah, a lot of hands were involved in this. Yeah.
Yes. And I remember this project being discussed in like 2014. So, I think it started even years before then. So a lot of work, but it's done and it works, and I'm very happy about it.
Yeah, people can use it. Yeah. But that's not all in the review or in the report.
The other one that I was interested in is an update on the port of Ceph to FreeBSD. Ceph is a distributed object store and file system designed to provide excellent performance, reliability, and scalability. So something like that you can stack on top of ZFS to get a cluster file system or a distributed file system would be great. It provides an object store, which provides seamless access to objects using a native language bindings or a REST interface that's compatible with applications written against the Amazon S3 or the OpenStack Swift protocol. It also provides a block storage. Ceph has called a Rados block device, or RBD, provides access to block device images that are striped and replicated across the storage cluster. So you can make a block file system that's actually backed by multiple physical machines, optionally all running ZFS. And it also has a file system. It provides a POSIX compliant network file system that aims for high performance, large data storage, and maximum compatibility with legacy applications. So it can provide a file system that's actually made up of multiple ZFSs underneath. So the person working on the project says, I started looking into Ceph because the hash solutions with Carp and Ggate and so on were not really ready to do what he wanted to do. I aim to run a Ceph storage cluster on storage nodes that are running ZFS, with user workstations running beehives on top of the RBD block devices. So these would be virtual block devices backed by multiple physical machines running ZFS in a redundant way so that a whole machine can go away and the beehives will keep running. So now, compiling for FreeBSD will now build most of the different tools for Ceph. The most important changes since the last update were that Ceph has released a new release candidate, 12.1.0. The corresponding packages are sitting in a work tree and waiting for it to actually be released. There's a Ceph Fuse project, and that works and allows mounting of the CephFS file system. The speed is not impressive, but it does work. And then there's the RBD-Ggate, which is available to create a Ceph RDB-backed device. The RBD-Ggate was created by Mykola Golub and works in a rather simple fashion. Once a cluster is functioning, you do RDB import and RDB Ggate map, and then it's used to create a Ggate-like device that actually talks to the Ceph cluster. So you get a native FreeBSD block device that's actually backed by multiple physical machines.
Cool.
Other improvements since the previous status report, they fixed some bugs in the init code that they were using for the rc.d scripts. The RBD and Rados are now completely functioning, and the needed compatibility code was written so that FreeBSD and Linux daemons can operate together in a single cluster. So you can actually build a cluster with some FreeBSD machines and some Linux machines, so that in the case of, say, a security update where you need to reboot all of the Linux machines for a security update, part of your cluster is FreeBSD can stay running. And they've also, more of the awkward dependencies and Linuxisms have been deleted. They've kept some of the stuff that depends on Bash and actually pointed it to Bash, but most of the other Linuxisms are gone now. So the next forthcoming official release of Ceph will be called the Luminous, version 12.1.0. As soon as it's available from upstream, the port will be available for FreeBSD. To get things running on FreeBSD system today, you just have to install net-ceph-devel or clone the GitHub repo and check out the work-in-progress FreeBSD branch. The parts that do not yet work are KRBD, which is a kernel device for the block storage, but because we have the RBD-G gate, you don't really need that part yet. And BlueStore. The FreeBSD and Linux have different AIO APIs, and there's incompatibilities that need to be resolved somehow. Additionally, there's discussion in FreeBSD about the specifically AIO cancel not working for all device types, so that needs to be addressed. So the open tasks are run the integration test to see if the FreeBSD daemons will work with the FreeBSD Ceph platform. Make sure that FreeBSD and Linux not only can run on the same cluster, but a FreeBSD client can talk to a Linux server, and a Linux client can talk to a FreeBSD server, and so on. They want to investigate the key store, which can be embedded in the kernel on Linux and currently prevents building CephFS and some other parts. The first question is whether it's really required, or if only the kernel RBD device requires it. Scheduler information is not used at the moment because the schedulers work rather differently between Linux and FreeBSD, but at a certain point in time, this will need some attention, and he points to the specific file that needs to be looked at. They would like to improve FreeBSD's init scripts in the Ceph stack, both for testing purposes and for running Ceph on production machines. Work on Ceph-disk and Ceph-deploy will make it more FreeBSD and ZFS compatible. They would like to build a test cluster and start running some of the tautology integration tests on it. Tautology works to build its own version of the virt. It does not quite work with all of the packages FreeBSD already has in place. There are many details to be worked out there. And lastly, they would like to design a virtual disk implementation that can be used with Beehive and attached to an RBD image. So that project seems to be progressing very well, and I'm quite interested in that. I need to get some free time someday and actually build a little Ceph cluster with this and start playing with it.
Yep.
If you happen to have free time and start doing this, do write in and tell us how it goes.
Yep. Oh, there's another nice thing in the kernel section of the report called the Coda Revival by Edward Tomasz Napierala. So it's a small report, but it's very promising. He writes, Coda is a distributed file system developed as a research project at Carnegie Mellon University, descended from an older version of the Andrew file system. It got dropped from FreeBSD some 5 years ago, I think I remember that, due to not having been adopted for an MP-safe world. So multiprocessing wasn't a thing that could be easily done for this.
It couldn't handle multiple cores.
Yeah. And so now the focus for this current project is to bring it back into a sufficiently workable shape that it could return to the kernel. It is currently in a working condition, and work is underway to test it better, fix whatever issues are found, and commit it to 12 current. And this project is sponsored by Chalmers University of Technology. And the two open tasks are additional testing and to update the user space components like net/Coda client and net Coda server. Yeah, this looks promising. People.
So it sounds like shortly FreeBSD will have multiple answers to the distributed file system problem, which I'm sure will be quite nice to have.
Right. And there's also PNFS. Yeah, so
Yes.
there's a plan B, apparently. At least the title says that. So remember back when we were reporting from, I think, BSD Can this year, there was a table there by Rick Macklem showing off his work at the Parallel NFS. So this is an update, basically, of the work. So Parallel NFS is an extension to the NFS version 4 protocol that allows to file accesses within the single logical mount to be performed against multiple file servers, so with the potential for data access to occur in parallel. And the PNFS layout is in use, specifies how the division occurs among these servers, with metadata operations occurring against the main server, and the bulk data operations that are occurring via a layout-specific scheme between the client and the data servers. So he writes that his first attempt at a PNFS server using a clusterFS was a dud. It worked, but performance was so poor that it was not usable. This attempt is what he calls Plan B, only uses FreeBSD, with one FreeBSD server handling the metadata operations and multiple FreeBSD servers configured to serve the data, is not now ready for third-party testing. If testing by third parties goes well, he anticipates that the code will be merged into FreeBSD head in time for FreeBSD 12, and fairly recent FreeBSD and Linux systems should be usable as a PNFS clients for testing. This server supports the file layout, which is supported by both of these clients. There's no support yet for the Flex Files layout of mirroring currently, and he hopes to use the Flex Files layout to add mirroring support over the next year or so. Striping is not supported, and he has plans to implement those, or no plans at this point to implement them. The patched FreeBSD sources may now be accessed for testing by the Subversion or download as a gzip tarball, and they consist of a patched kernel and an NFS daemon, and that can be used on any FreeBSD 11 or later system. And open task for that is testing by others will be needed. So now that the code is available.
There's a link here with the instructions, and I definitely encourage people to check that out. I might need to start playing with that, because having mirrored NFS servers for a couple of my use cases at work would be a really big help. The way we serve websites means we have to have a single file store somewhere. And we do that with mirrors currently. We do that. We use an NFS so that all the different jails that are executing the website code share the same files. But if that one NFS server goes away, that causes us some troubles.
Yeah.
We can bring it back from a ZFS replica, but that's not quite the same as if we actually had a mirror setup such that, the NFS client would know, oh, that server's not answering. Let me just go ask this other server. So, yes, I need to play with this a bit more, but I would also be happy to have everybody else help test it as well.
Yeah, and send us how your tests are going, and we'll cover it in the show.
There are lots of other updates in here. There's stuff about new 25 gigabit per second NICs, an update about Intel's 10 gig NICs, ports of FreeBSD to the Marvel Armada 38X, and updates on ARM64. The updates on DTC, which is the
device tree
compiler.
Something? Compiler, yeah.
That's the device tree compiler, and there's also updates to DTS, which is the device tree source files that you compile with the device tree compiler. There's an update on using LLD, which is the Clang linker, to link FreeBSD's system, and I think that might end up being the default for 12 if it keeps going.
Oh, good.
They also a number of updates from the ports tree, including a new uses macro for porting REST applications that are based on the Cargo framework, updates to GCC, GNOME, KDE, PHP, Rust, the sound subsystem, TensorFlow, updating the ports metadata for non-x86 architectures so that it's easy to tell if an application is known to work on a Raspberry Pi or not, things like that. Updates to XFCE, and a new port called FR routing. FRR, is a fork of Quagga, the BGP daemon, is an IP routing protocol suite for Linux and Unix platforms, which provides protocol daemons for BGP, ISIS, OSPF, RIP with LPD and PIM support, and a bunch of other stuff. FFR is a Linux Foundation collaborative project with contributors including Sixwind and a bunch of other companies, including Beat Switch Networks, Cumulus Networks, etc. But that has a port to FreeBSD now. So if you're doing much routing, especially BGP stuff, you might want to check out this new, faster routing daemon.
Yep. The documentation section is small, but still has some important items. First, there's an update from Michael Lucas about Absolute FreeBSD, the 3rd edition. It's going to be coming out hopefully before BSD with print copies, 2018. I'm still reading his drafts, or not drafts anymore, but they are finished chapters. He's just doing tech reviews or just typo fixing and all that. But it's coming out well. The stuff that I wrote or read already, it's already looking very good. So you can look forward to that book. We also have a section by Warren Block about the doc version strings improved in their absence. This is about translations and also having so many of these documents have the $FreeBSD tag from some version in them to expand to like date and time when this document was last changed. And this is important for translation efforts. He wrote up the description in the report there. And, there's a small section by me. The new Zen handbook section. Yeah, I thought I should highlight this a little bit more. So I moved all the Zen instructions from the FreeBSD wiki into the handbook to have a little bit more focus on this area so people can try out the Zen support that we have. It's not full Zen support, but we can run DOM zeros and DOM unprivileges.
It's
unprivileged.
Pretty good. Like you can run VMs on top of FreeBSD that you can live migrate.
Yeah. And the only thing that doesn't work is device redirection for PCIe, but that's listed in the handbook. So
yeah, well, device pass-through is kind of specific anyway. But the Zen support is really cool, and doesn't have some of the caveats that running things like Beehive does, and there's a lot more tooling existing already. So yeah, people should definitely play with it. Mm. And having instructions that work is very helpful. So thank you very much.
Yeah. I'm trying to convert more stuff from the wiki that is mostly finished into the handbook, but it needs time for rewriting and review. And it's nice to see that once people start translating them, they find additional stuff. So this happened by Björn Heidotting, who was translating this to German. Well, I could have done this myself, but having someone else do this is nice. And then you translate the string, and it's like, oh, there's a typo there. I should submit this upstream into the English version as well. So that's a nice feedback loop here. And what's left? Miscellaneous has a BSD meetup in France, or in Rennes. I don't know how to pronounce that properly. Sorry.
Yep. So there will be 2 meetups dedicated to BSD held in Rennes, France. The first one was hosted at the offices of OVH, which is a big hosting company, and included presentations on multiple subjects, a non-technical history of FreeNAS, presented by Olivier, who founded the FreeNAS project many, many years ago. One on how OVH is using ZFS, an introduction to jails, and the use cases for BGP/Bird on FreeBSD. The second meeting, also hosted at the OVH offices, presented the subject on how to create a FreeBSD port, how OVH is using finite state machines for managing their storage system, network high availability with FreeBSD, and a jail tutorial by means of a demonstration running 200 OSPF routers using jails and VNets on a small PC Engine's APU2 with only 4 cores. So actually running 200 separate routers, one for each customer, on a tiny little APU like the ones we used to give away at BSD Camp.
Yep, that's impressive.
Mm-hmm. And there's a third-party project section with an update from Hardened BSD. Mm-hmm. But there's lots of stuff in there. So you should definitely go check it out and read more about what you're interested in. We just picked out a couple of things that we were particularly interested in to talk about.
Mm-hmm. And if you have a story of your own, the deadline for submissions for the 3rd quarter status report is from basically September 20...
from July to September.
Yeah,
anything
right.
you worked on between July and September, you need to write the report and send it in by October 21st.
Yeah.
There's a simple form to do it with. You can write just the text and they'll take care of the formatting if you don't want to learn how to do DocBook.
Yep. So thanks to the monthly team at FreeBSD for writing up these and making them look nice as a report.
It's a great way to explain to people what it is you're working on and to get their feedback and to get their help. It's often the way you end up getting people to come help or test something or work on something together is by telling them that you're doing it.
Yeah,
so much goes on
testers
very quietly in FreeBSD, right? And you work on it and maybe you tell a couple people, but you don't necessarily have a way to tell everybody in the world that you're working on this. The quarterly status report is one way, although you can also just email feedback at bsdnow.tv and be like, hey, I'm working on this. Is anybody else interested in helping?
Yep. Yeah, we'll get the word out and hopefully you can get a lot of feedback and testers.
Mm-hmm.
So
this week's episode of BSD Now is brought to you by IX Systems.
Exactly. The vendor for storage, servers, and solutions driven by open source. So if you check out ixsystems.com/bsdnow, you can get a PDF to download for free, which is a server buying guide for open source. So in case you are wondering, well, I have this open source project and it probably needs a lot of storage and a beefy server. What should I ask my vendor in case I want to run this, or I certainly want to run this on open source? What can they provide? And these are the questions that you should ask other vendors or IX Systems, and you will certainly find that IX Systems has an answer for all of these, and a very compelling answer, that is.
Yeah, or, if you were just listening to our story from Netflix and were wondering to yourself, what's the difference between an E5 2697 and an E5 2697A? Well, the answer is quite a bit. The 2697 is 18 cores at 2.3 gigahertz, but the 2697A is only 16 cores, but they're at 2.6 gigahertz. And the amount of cache is different, and there's some other differences. And so, oftentimes it comes down to just knowing that little bit about that. And it's like, do I want that, or do I need a 2699A, which is 22 cores at 2.4 gigahertz?
Yeah, which is more... And I mean, for some servers that you are trying to build up, it's more important whether they have a more beefier CPU, or do you want to put more memory in them, or bigger disks. So it's everything that you should ask IX Systems, and they can give you the right answer to your specific server need.
Yeah, so in particular, it can come down to, depending on your workload, is it cheaper to just buy a machine with two 2620 V4s, so giving you two 8-core CPUs, or do I need to spend all this money in order to get a 2697A, which is 16 cores in one CPU instead of two separate CPUs? All these different questions you could end up with. It really, really helps to have someone that knows all of the Intel stuff inside and out and can help you. So, they, first of all, have all of those processors, right? You're not looking at a couple of machines they've already built on the shelf and they're trying to sell you. They custom build every system for you, but they do it quickly. So it means you need to talk to them and explain what it is you're trying to do, because it makes a very big difference on helping them decide which one of these parts is the right one for you. If you just be like, I want the most gigahertz, then, they can sell you that, but it doesn't necessarily give you the best solution. Whereas if you can actually explain your workload to them and what you're going to do with it, they can help design the best possible system for your use case.
Yeah, and they thoroughly test it before they ship it to you, so you can make sure that the disks won't die after the first week, or some other components might fail. So they have extensive testing.
You got this nice new system, and it's got a defective stick of RAM, and so it keeps crashing in very strange ways. They deal with all of that ahead of time for you by burning them in for 72 hours before they ship it. Considering that they're custom building every machine for you, they get them shipped very quickly as it is. And that's with 3 days of testing after they build it. But, for whatever you need on the Intel scale, or, maybe you finally mastered what the difference between a 2697 and a 2697A are. And now they've gone and changed all the names because, is that a 4114 silver? What's the difference between silver and gold? And
yeah, I've lost.
Yes, all these questions. But IX Systems has the right people to answer the questions and solve the problems and builds you a solution that actually solves your problem rather than just selling you a server.
Yep. So check out their website and tell them we sent you.
Mm-hmm. While you're at it, do check out their blog. They always have interesting stuff going on there. In particular, I think right now they have reports from a number of conferences they went to, including EuroBSDCon, SNIA, which is the Storage and Networking Industry Association, VBSDCon, and I guess they will have one very soon from Ohio Linux Fest as well, where they were there representing FreeBSD amongst all the unwashed Linux people. Oh, and here they have the server envy thing we talked about last week a little bit, I think. The full story of this 60-drive storage server. All right, so last week, 5 of these monster systems rolled through our production floor, and they thought they'd share. The 4U server is an IX4260 from their Jupyter series. It's a 60-drive-based system, providing more storage than you can imagine. So top-loading 60 drives. This particular order is populated with 60 10-terabyte HGST Helium Ultrastar hard drives for a total of 600 terabytes of raw storage in each of those. With 1 to 7 of the density of air, or 1/7 the density of air, helium allows these drives to be thinner and fit more platters. And you can see it's just full of fans and power supplies here.
Yeah, this is certainly a beefy machine for disk space.
The system also has 2 800 gig Intel SSDs, 8 sticks of 16 gigs of RAM, and dual Xeon 10-core processors. So actually, this one's not just a storage sled, it's a whole system.
Yeah, it seems to be a system that's doing some heavy work.
Yeah. That's pretty.
Server envy already starting. Yeah.
Yeah. Anyway, you should definitely get in touch with them if you need something like that. Next up, we have news from DPDK, which is the Data Plane Development Kit Conference. They make a set of tools for mostly networking, doing network packet processing stuff on a wide variety of CPU architectures. And at their conference, they had a little update segment where they updates from a number of different projects. In this case, we have highlighted an update from the Pfsense project. So the video starts with a quick introduction to Pfsense and the company behind it, but then it talks about Pfsense history a bit, starting with a couple of years ago when they started trying to scale Pfsense to be able to do 10 gigabit networking and beyond. And some of the solutions they tried, like libuinet and netmap and packet journey and so on. But then earlier this year, well, in Japan for EuroBSDCon, they discovered VPP, or Vector Packet Processing, a new software project from Cisco. So then the video covers what the architecture of the next major version of Pfsense will be like, and the different components of that, and then talks a bit about the future of Pfsense, including the fact that it's now available as an appliance on Amazon EC2, shortly will be available on Microsoft Azure, and most interesting, in November of this year, they will launch support for Intel's new Atom C3000 and the Xeon hardware that has built-in QAT, which is Intel's Quick Assist. Previously, Quick Assist was a separate PCI card that you might install in a server, but newer versions of their new generation of the Atom and some of the Xeon Ds and so on will have it built into the motherboard, providing some degree of compression and crypto offload. And they've been working to get drivers for that and get them into FreeBSD.
Excellent.
They also talk a bit about the future plans for Pfsense, which is scaling up to 100 gigabits, support for MPLS, VXLANs, and other high-end routing stuff like GRE and so on, and support for the ARM64 hardware architectures. So if you're interested in Pfsense, I think it's about 10 or 15 minutes of an update, and it's definitely worth a watch.
Mm-hmm. Yeah, it seems like we're going to cover Pfsense a little bit more in future episodes. They seem to have good news coming up.
Mm-hmm.
So after our headlines this week, we are going to dive into the news roundup. The first item there is the local nginx reverse proxy cache for FreeBSD update. So we found this on the wiki.freebsd.org. It's a write-up by Vladimir Kirstulia. So he has a bunch of guides written, and one of them picked my interest because it's a FreeBSD update reverse proxy. So what this does, basically, there's a new release coming out in your infrastructure, like the currently appearing 10.4, and all of your machines are basically doing FreeBSD update, and they go out into the internet and get their updates. But then you're thinking, well, why is every system going to the internet? I should keep a local proxy so they can fetch the stuff quicker from my local LAN.
Yeah, if you have a data center or a campus or whatever, and you're going to have tens or hundreds of machines, you might as well cache it and make it go a lot faster.
Mm-hmm. And this is what this how-to provides, basically. It starts with either because you're a good netizen and don't want to repeatedly hammer the FreeBSD mirrors to upgrade all your systems, or you want to benefit from the speed of having a local mirror, like a cache more precisely. Running a FreeBSD update reverse proxy cache with, say, nginx is dead simple. And basically, of course, first step is always you need nginx, so you have to install nginx somewhere where your systems should all go and get their cache data from. And then there's a configuration section for nginx for a subdomain, which basically adds a little proxy cache section. Yeah, and that's pretty much so. The root for this one is basically your /var/cache/FreeBSD update, and that's where all the other systems will get their updated files from. And nginx is basically providing the access in a reverse proxy cache way. Then step 3.
In general, you don't have to worry so much about invalidation for this because it's all hash-based. So if the file changes, the name will change, and so it's fine. I guess you maybe have to worry about the metadata files, but in general, it's all good.
Yep. And then on all your hosts that are using that cache, you configure that in /etc/freebsd-update.conf. You add a new server name section there. You basically uncomment the update.freebsd.org entry and put your own server name in there. And that's it already. Running FreeBSD update will use the server name domain, which is your reverse nginx proxy. And note the comment about using a nearby server is not quite true. FreeBSD update mirrors are frequently slow, and running such a reverse proxy cache significantly speeds things up. There are some caveats here, of course. This is a simple cache. That means it doesn't consider the files as a whole repository, which in turn means updates to your cache are not atomic. It'll be advised to nuke your cache completely.
Like I said, because it's hash-based, it should all be fine. I think some of the nginx config might be missing because they mentioned they use proxy cache FreeBSD_update, but they don't actually provide the config that creates that. There might be 1 or 2 lines missing from that.
If only you had wiki access to change that.
I'll have to try that out later and fix it.
Yeah,
I think it's 1 or 2 lines that would go at the, outside the server block that would create the FreeBSD_update cache thing. I think you have to provide the path and the maximum size and so on.
Things like that. But yeah, it's a good way. It's certainly an interesting approach, and if you have really a lot of systems to upgrade, then it's certainly
if you have a lot
better.
of systems or are just bandwidth constrained, that would definitely be an improvement.
Yep. So check out that guide, and thanks, Vladimir, for writing that.
So next we have an update on CloneOS, which is a free open source FreeBSD based platform for virtual environment creation and management. So it sounds kind of like it's trying to be SmartOS, but based on FreeBSD. But it's a free open source FreeBSD-based platform for running a virtual environment. So it uses FreeBSD, Beehive or Zen, the Valley NetMap switching, Jails, the CBSD project for management tools, and Puppet.
All the good components are there.
The idea is to be a solution kind of like OpenStack or OpenNebula or Amazon AWS, but using FreeBSD, because you get it uses ZFS. You can do VM clonings, imports and exports, an Ethernet soft switch with Valley, jails for lightweight containers, VNC termination for both VMs and containers, templates for your VMs and containers, configuration management and helpers with Puppet, a multi-node operation, and many more. And it's all based on various open source bits. And they have some videos and screenshots. It looks quite nice.
Yep. Of course, it's all powered by ZFS, and VM cloning, export and imports are possible. So that has some compelling features and a nice GUI. So you should check that out if you're interested.
Yes, so CloneOS can be downloaded as an image file or for USB stick or an ISO for CD. It's about 1.6 gigs in size. Booting from the media, it provide a text console asking us to select what text console you want to use. The operating system on the surface appears like a regular installation of FreeBSD 12. The usual collection of FreeBSD packages are available, including manual pages and the compiler and that kind of stuff. Once it's fully installed, it uses about 3.3 gigs of space and requires 50 megabytes of memory and so on. Most of the key features of CloneOS, parts that are apart from vanilla FreeBSD, can be accessed through a web control panel. When you connect to the control panel over plain HTTP using your web browser, you're not prompted for an account name or password. The web-based interface has a straightforward layout. Down the left side, you find all the categories and options and controls. And on the right side, you'll find the specifics for each category with like the list of VMs or whatever. Currently, it's available in both English and Russian, with English as the default.
Okay.
So you have your jails and containers, as well as templates, your Beehive VMs, your VPNs, your SSH keys that you've set up, storage media, which allows you to upload ISOs to be able to create new virtual machines from, your FreeBSD base images, which allows you to download and build source code for alternative versions of FreeBSD, task log, which browse everything that's happening on the machine, an SQLite admin allows you to poke at the database in case there's a problem or whatever, and a settings page. So while playing with CloneOS, I wanted to perform a couple of simple tasks. I wanted to use a WordPress template to set up a blog inside a jail. I wanted a generic empty jail in which I could play and run commands without harming the rest of the operating system. I also wanted to try installing an operating system other than FreeBSD inside a Beehive environment. I thought that would give me a pretty good idea of how quick and easy CloneOS would be to do these common tasks. And their conclusion was CloneOS appears to be in its early stages of development, more of a feature preview or proof of concept than a polished product. A few of the settings panes have not been finished yet, and the web-based controls for jails are unable to create jails that connect to the network, and I was unable to upload a small ISO. However, the project website mentions working with Puppet to handle system configuration, and they didn't get to play with that. One of the biggest concerns they had was the fact that it doesn't have an authentication system yet, but you run that on an internal network and you can put a nginx or something in front of it to provide HTTPS and authentication if that's all you're after. But yes, eventually you would like to have multiple users with different access levels and so on.
Yeah, otherwise there will be trouble.
But looks like an interesting start, and it's open source, so if you're interested in it, play with it, kick the tires a bit, and then maybe contribute back patches.
Yeah, some small things, or even the missing authentication could be implemented. Yep. So I think that's certainly something to look for in the future.
This week's episode is also brought to you by DigitalOcean. Head over to digitalocean.com and spin up a FreeBSD VM in the cloud.
Yes.
The biggest advantage to this is just that versus a VM on your computer, it's not slowing down your computer. It stays on when your computer turns off or reboots or whatever. And it has a public IP address out on the internet and a gigabit connection to the internet.
Yep.
Most people don't have a gigabit connection to the internet at their house with a little VM.
Yeah.
Everybody should have access to a FreeBSD machine that only they have access to do random things. And at $5 a month, it's pretty hard to argue that you can't have a FreeBSD machine.
Yeah, why shouldn't you start with this already? And you can also select which data center it should reside in. So if it's closer to, if you're in Europe, then you can pick London, Frankfurt, Amsterdam. Or if you're in North America, you can choose San Francisco, Toronto, or New York City. And they also have Bangalore and Singapore data centers available.
Yeah, so you can get a machine close to you or far away if you want. And it's just a great way to be able to have a FreeBSD machine that you have access to out there somewhere every time you want to do something. Whether if it's just to have a FreeBSD machine to play with to learn things, or the best way to learn FreeBSD is to set it up and do something. Like, I want to build a web server, so set it up to do that. And then make it do a mail server, or,
anything you want.
Updating, install FreeBSD 10.3 and then upgrade it. Or whatever you want to do.
That's certainly the flexibility they provide for you.
And because it's virtual, they also have a HTML5 console system, which allows you to get to the console of the machine even if you break the operating system.
Or the network.
Which makes so it makes it very easy to fix things when things go wrong, whereas with other remote systems, that's usually not that easy. And you can even use that console access to erase FreeBSD and install NetBSD or OpenBSD or Dragonfly BSD if you want.
Yeah, so it's not limited to the FreeBSD they have prepared already.
But, one click and you can deploy FreeBSD virtual machine with UFS or ZFS. If you've been hearing us talk about ZFS all the time and you'd like to try it, but you don't want to reformat one of your machines, for 0.7 cents per hour, you can rent a ZFS machine out in the cloud with fast internet and try things on it. And if it breaks, you can just delete it and create a new one.
Or roll back to your snapshots.
Yes, you can also snapshot and roll back too.
Yeah, so a lot of possibilities in DigitalOcean's cloud.
But yes, go check it out, play with it. When you do, use the coupon code FreeBSD now, and it'll add an extra $10 of credit to your account so that you can keep learning FreeBSD on us.
Yep, for a little amount to get started.
Next up, we have an OpenBSD article. Tell us a bit about this.
Yeah, so this is customized the Corn Shell, KSH, the display for OpenBSD. And this is a blog post. It starts with the default shell for OpenBSD is KSH, and it looks a little monotonous. So there's just a listing here, not very pretty, no highlighting, no colors, no nothing. And
looks like they've managed to crash HTOP.
Oh, right. There's a core dump here. Oops. That's just for debugging purposes. They're working on something. Okay. To make its user experience more friendly, that the blog post owner basically needed to do some customizations. So first, modify the prompt string to display the username and current directory. So this is a typical PS1 where you echo the $user and $pwd to your prompt so that you can see each time which user and at which directory you're currently in. Second is the installation of the color ls package, which gives you your ls colored in a little bit of different colors, like for directories or symlinks. They have different colors then, and you can customize these, of course. They use it to replace the shipped ls command with an alias, and you can put that in your Corn Shell initialization file so that you can have color ls/G. And if you replace that with ls, then you can already see that your environment looks a little bit different, more colors. The third thing is to change the ls colors environmental variable you would have to make your favorite color. For example, he didn't want the directory to display it in default blue, so he changed it to magenta. And there's a
it's kind of a
magenta, yep. And there's the color code for that. It's provided in the blog post as well. And for the detailed explanation of the ls colors, you can refer to the color ls manual page, of course. That's where everything is described, how the colors are being mixed together if you're looking for a certain color.
Yeah,
and
to figure out what that string of letters means, which basically it's a foreground color, background color pair for each of the different setups.
Mm-hmm. Right. And if you want to save those for after reboot, because after you log out, those sessions things are gone unless you put that into your .profile. There's also a listing here where you put all these information in there and export them as well so that they are active each time you log in. And there's a screenshot how this will look afterwards. So there's a little bit more color there. The htop core file is still there, but you can probably ignore this. So
you see
it's
now
a nice...
the directories are in magenta.
Mm-hmm. Yeah, so this is a nice colorization and giving your OpenBSD shell a little bit more than the just black and white or gray and black, whatever it is. Okay, what's next here? I read something about
Dragonfly 5.0 is about to come out.
Oh.
They have a link for you to download the release candidate. It's actually release candidate 2 already because they had to back out the recent Radeon changes, which were what RC1 had.
Huh, okay. So that will be the one that has the Hammer updates? Hammer 2? Oh, very nice.
Yeah. I've heard from people in the chat room already who are running Hammer 2 and having fun playing with it.
Yeah, I should at least try it out a little bit so that it can make a better judgment how this versioning thing goes and some other features that it has.
There are some really cool features in Hammer 2.
Mm-hmm. Yeah, so people who are running Dragonfly should check out the release candidate, and if it's coming out in the future, then we'll cover it in the show, of course. So it's time for our BSD section this week, starting with faster forwarding up over at grenadille.net.
Yes, so this is an update on an article we covered before about OpenBSD, where they found that adding VLAN interfaces to the forwarding path hurt performance a bit. But they said since a couple of months ago, the processing of incoming IP packets on OpenBSD now no longer requires the kernel lock. The first consequence of this is that it improved latency on the system, but apparently it's made packet forwarding about 20% faster. So using Pfsense's system that they're measuring, which is a Xeon E5 2643 V2 at 2.5 gigahertz, he reperformed the VLAN regression testing that they had done before, and they measured that on his machine now, instead of 1.42 million packets per second, with the Dash current kernel, they get 1.75 million packets per second, about a 20% improvement. Even though most of the stack is still single-threaded, contending less on the couple of locks they've removed so far has already improved performance by 20%.
Okay, well, that's progress. Very cool. Next up is DRM Next Kmod hits the ports tree. So this is over at Freshports, of course. And so this has been committed on the 29th of August, 2017. And this latest update is from September 20th, 2017. So for those people who don't know what we're talking about here, this is AMD GPU i915 and Radeon DRM modules for the Linux KPI-based KMS components. They currently correspond to...
Yeah, this is
Linux.
The port of the Linux graphic drivers to FreeBSD so that you can use the integrated Intel and AMD graphics on newer laptops and so on. But it also actually does include the Radeon module for discrete graphics on desktop type machines as well.
Mm-hmm. Yeah, so people check that out, and hopefully their laptops will all provide the right graphics this time.
Yeah. So that's still a work in progress, but it's getting to the point where you no longer need to run a custom everything in order for it to work. You'll be able to just install this package and pull it all in that way.
Yep, and hopefully be on your way with better DRM graphic support. Mm-hmm. Okay, next up, OpenBSD community goes platinum. Ooh, that sounds nice, over at undeadly.org. Oh yeah, this is from Kenneth R. Westerback, wearing his developer hat. He wrote to let the OpenBSD journal know that PayPal and Bitcoin donations from the OpenBSD community have made the community the OpenBSD Foundation's first platinum level contributor for 2017. Excellent. Monthly PayPal commitments by the community are our most reliable source of funds and thus the most useful for financial planning purposes. We are extremely thankful for the continuing support and hope for the community matches the 2016 achievement of Iridium status. So you should sign up now for a small monthly donation at openbsdfoundation.org/donations.html. Very nice. Yeah, this is cool to see that they're very well supported by the users and the community.
Yep. And lastly, we have a YouTube video tutorial. It's about almost 40 minutes long, and it's how to set up iSCSI shares on TrueOS and FreeBSD 12.
Oh, very nice. So people who
also covers FreeNAS actually, but
yeah, probably. I guess this is a similar stack or a similar setup, and so people can export their portions of a disk or a full disk even over to another machine, and this will appear not as a network file system but as free local storage, but it's coming over the network. So this is what iSCSI provides.
Yeah, it shows up as a block device locally.
Mm-hmm. And you can reformat it and put a new file system on it and do all kinds of crazy things with it. So it's easy to extend your local storage this way over the network. You just need an iSCSI initiator and an iSCSI target where you can pull this.
Yes, iSCSI support is built in to things like Windows and FreeBSD and so on, so it doesn't require any extra software. You can just fire it up and suddenly you have this extra block device. It looks like a hard drive, basically.
Mm-hmm. Yeah, very nice to have people record videos about these setups.
Right, so this video is actually only about 14 minutes long. It seems that I left the tab open and it played the whole video and went to the next video, and that's why it was confusing me. So yes, this is just on how to set up iSCSI shares on FreeBSD 12 or TrueOS, and it's about 14 minutes long.
Okay, that's quick and yeah, it's not too complicated if you know what you're doing and which files to have to edit.
Indeed.
Speaking of files, by the way, you should back them up regularly. And if you want to do that, you should probably use a service which is in use for, or which is the sponsor for our feedback and questions section, Tarsnap.
Well, really, what you should use is the only secure backup service that exists.
Right.
What other backup service do you know also gives you the source code for the client program so that you can audit it yourself or have someone else do it for you or whatever? Tarsnap is the only one that can guarantee that, you encrypt it with your key and that key is not available to anybody else.
Yeah, and they even provide on the front page the full story, why you should use Tarsnap. So there's a typical backup scenario listed here, that Alice begins a backup, which takes a complete snapshot of her files, and then Tarsnap automatically finds the unique data within her files. Alice pays less than $5 per month, which is affordable by anyone, basically. It's a pizza, basically. And then Alice's data is secure because she's the only person holding the decryption key, and all the files that she's updating or uploading are encrypted. No one else can read them or can make any sense of them because she has encrypted them locally, and the Tarsnap did all the magic around that with uploading and downloading and all that specific.
Plus, it deduplicates and compresses everything first, so it uses the minimum amount of bandwidth as it can.
So this is the perfect solution for you if you need to keep a certain number of files around, and if you want to retrieve them from the cloud, and it's safe to say that you're the only person holding the key.
In particular, if you want to put your files in the cloud, but know that A, you can securely delete them from the cloud, and B, that no one else can access them. There is no way to securely delete things in the cloud. But if they're encrypted and you destroy the key, then they can never be decrypted, and they're effectively destroyed.
Yeah, you don't have to worry about that. Yeah, so check out tarsnap.com and try it out for yourself. That's the best way to use it. Okay.
So head over to tarsnap.com/BSD now. Try it out. It only takes $5 to get started. What are you waiting for?
Yeah. Well, people want to certainly end the show before starting that. But yeah, we won't hold you. All right. The feedback and questions section is this week a little bit slim, so we're still asking people to submit questions, blog posts, anything they have that they want to mention, and we'll cover it in a future show. But you can only do that if you send us something. So send us your stories at feedback@bsdnow.tv, and then we have a chance to cover it in the show. Like Christopher's stories, for example, about virtualizing FreeNAS. He writes, "Hi guys, I love the show. I appreciate the podcast that doesn't hold back on getting deep into the nerdy details. Please keep it up. Thank you." So he tries to install FreeNAS on his home for backing up his photos, but he writes, "But I'm not in a position to purchase hardware anytime soon. So he's considering virtualizing it on his desktop. He wants to dedicate 3 HDDs in RAID Z1 to FreeNAS and use a separate hard drive for the desktop OSs, like dual booting between Windows 7 and with VMware, and Zen with Fedora as DOM0. The box has 32 gigabytes of RAM, which is hopefully enough, I think it is. But can it do PCI pass-through on both host OSs? And when FreeNAS loads the Z pool from the disk, will it just work?" And he also writes, "Can I even do PCI pass-through with a SATA drive connected directly to the motherboard SATA headers using Zen and Create? Hoping you could direct me to something that isn't liable to corrupt my Z pools and trash my photos."
So in general, for PCI pass-through, it would be an entire device. So you can't do individual SATA ports. You could only do all of the SATA ports built into the motherboard that are on one controller, or a whole like PCI disk controller. And I don't know how you do PCI pass-through on Windows, because you have to stop Windows from loading a driver for the device and so on, and I don't know how any of that works.
Yeah, with VMware.
But like a Zen DOM0 on Fedora or VMware type thing, sure, you'd be able to PCI pass through the controller, but then your VMware or Fedora or whatever has to run off not a hard drive connected to that controller. So
yeah,
some motherboards sometimes have 2 separate controllers, but that's kind of unusual.
Yeah, it's we're already starting with a different setup for just the FreeNAS and to back up your photos. I mean, you should have dedicated hardware for backup purposes, not something virtualized that has a lot of layers where things could go wrong. Mm-hmm. That's how I would do it. I wouldn't add an additional
it's possible to do, but dual booting Windows and your Fedora thing gets much more complicated. And then PCI pass-through without, a dedicated disk controller means that, the disk for the thing that's going to do the pass-through has to not be on the same controller, and that's probably not an option.
Yeah. I mean, if money is short, then certainly, but if you're doing it on your desktop PC, then there's, and if you store the the photos there, then I'm not sure how long this will last. I mean, it's possible, certainly, but it's not an ideal setup.
Yeah. PCI pass-through, I don't know how you would do it on Windows 7. With VMware Zen, slightly possible, but you can't pass individual SATA ports through, only the entire controller. And if you do that, then the controller is then invisible to Fedora or VMware, and then if that's where the hard drive that Fedora or VMware is supposed to boot off of exists, then that won't work.
All right. And with zpools, ZFS is best when it has direct access to the disks. I mean, with forwarding, that's all.
Why they're trying to do the PCI pass-through, but
there's still another layer between the two.
Yeah, you're making it very complicated, and you're getting into territory of nobody else does it that way because that's too complicated.
Yeah.
So I can't tell you how that might work because I would just not do it that way.
Yeah. Oh, well, maybe you... I mean, it doesn't have to be the most expensive hardware. There's still... Well, you can maybe find something in the refurbished section, or maybe someone else has an old PC that's not being used anymore. That's a perfect backup device. So maybe that's an option. But I think we can't help much more in this question.
So next question.
Mm-hmm. The next one is from Van, a TAR question, and it starts with, after listening to last week's show of the 23rd of August, he had a question, for the gentleman who wrote in regarding naming storage pools after Starship registrations. Are those pools specific to function? For example, would NCC 1701 be reserved for enterprise storage? Ooh, yeah. Oh, yeah. Sorry, couldn't resist.
We actually met that user at VBSDCon.
Oh, right. Yeah. Yeah. Okay. Question regarding jail setup for the handbook page listed here. So that's on the FreeBSD handbook. In a section about extracting distro files, so that's the tar extract into the destination directory of the base TXZ, to install everything except the kernel. So for sets in base, so you basically have a for loop here, looping all over the distribution sets with the destination dir. Should the second path be /mount/user/FreeBSD dist? That appears to be where the tar files are being mounted in 11.1 release. Oh, this could be an error with a new updated
It looks like
path.
it might have been a problem with the conversion from the old setup. Yes.
Yeah, that could be. Also, that's
that for loop is from before, and it looks like we just missed it when we changed the paths around.
Yep. To do for us in the documentation area. We usually get these as bug reports, but as feedback into the show is also a way of reaching us.
Yes.
Yeah, this is certainly...
You are correct, and you should make a diff and submit it, and then become a FreeBSD documentation committer, and then fix hundreds more of these, and make the handbook better for everyone.
Excellent. Why haven't I thought of that? Yeah, definitely. That's your first step.
Thank you for noticing, and please submit a patch, and we'll get that fixed and give you credit.
Yeah, and everything will benefit from your fix, because everyone who wants to build a jail, who stumbled over that section not working, can now benefit from your patched version. Cool. So thank you for the submission. And last but not least is Joe about book reviews. He writes, howdy. As some of you know, the FreeBSD Journal has been publishing book reviews somewhat regularly. Because of this, publishers continue to offer us books to review. Unfortunately, we can't review all of these books personally. We need people like you to help us. If you're interested, please send your name and the types of books you'd like to review, like programming, kernel, sysadmin, and so on, to journal@freebsdfoundation.org. And alternatively, you can email Joe directly. A book review only needs to be a few paragraphs long and maybe focus on, does this book accomplish its stated purpose? Best, Joe. Right, yeah, this is true. So we have regular, I think it's twice per...
Every 2 months.
Every 2 months, yeah. So we have an editorial board meeting. It's a hangout, basically, and we also have one at BSDCan in person, where we discuss, upcoming issues, and many of these issues are still lacking book reviews, and we want to have people who have read an interesting tech book or found something interesting that they would like to review, to submit them into the journal at freebsdfoundation.org.
At this point, they've actually got publishers offering to send free books just to get the review, so they just need people that are willing to spend the time to read the book and see and write a little bit about how it was.
Yeah, so this is a win-win for everyone.
Yeah,
you get
if
the
you
book,
would like some
you get
free
a
tech
review.
books in exchange for writing moderately short reviews, they get published in the FreeBSD Journal. then please get in touch with the journal at freebsdfoundation.org.
Yep, very good. Oh, that's it for this week, I think.
It is.
That was another nice show and another great content from all the BSDs, I guess.
Mm-hmm.
So yeah, again, if you have something for us to cover in the show that you found about BSD, then send it to feedback@bsdnow.tv, and we'll make sure that it will end up in one of the future episodes. And if you have questions, again, same URL, and yeah, we'll cover everything that you have in your BSD.
If you've emailed something and you haven't seen it yet, remember that we're pre-recording a bit here, so it's spread out a bit. And, when you're watching this episode, we actually recorded it a week ago already. And then next week's episode, we recorded it like 2 weeks ago. It's going to get a little crazy. But we need your feedback as soon as possible so that we can not run out of feedback when we're getting a couple of weeks ahead here, to cover the fact that it just turns out that the Open ZFS Developer Summit is exactly 1 week before Lisa and the FreeBSD Vendor Summit, which is like 1 week before I leave for BSD Taiwan, meaning 3 Wednesdays in a row where I'm not at home.
Oh, yeah. And by the time this show comes out, I have a couple of students. So my lectures start next week, or if you're watching this week, and I'm sure I can drive some of them to at least look at BSD Now. So there might be some questions there. I mean, they could be easy questions. There could also be questions where you don't understand anything, and we'll try to help you. And if we can't help you, then there's a lot of other people watching this show who can also provide feedback.
The question doesn't have to be for us. It can just be for everybody that watches. And, as like the one we had last week, it doesn't necessarily have to be a question. It just has to be comment or feedback about the show, or just a thank you is fine. Whatever.
Yeah.
Just also, if you have an idea for something we should talk about, or a specific story that you feel we didn't cover, email it in and we'll work on it, We only have so much time. Right. If you enjoy the show, you could pick up a little bit of the slack by sending in one story.
Yeah, definitely. Yeah, and it's nice to see your story being covered in an episode. So yeah, thank you for watching.
Is if you're doing something interesting, write a blog post about it and send it to us. I was just watching on Twitter, somebody's got the Onion Omega 2 working. After I did a bunch of the work to get the Onion Omega 1 working, and then the 2 wasn't the same, and I was like, oh. And so my Omega 2 is sat in the box it came in since it got, as all so many ARM boards do, but MIPS in this case. But yes, I saw somebody working on it. It's like, please write a post about this so that we can work on it. And, I want to tell other people about it.
Yeah, so the more people submit something, the more we can spread the word about the BSDs.